Okay, so we've been talking about nuclear radiation and so on a little bit, isotopes and atomic structure. At this point, what we want to talk about is specific kinds of nuclear radiation, basically particles that can be emitted from a nucleus. So there are three kinds of nuclear radiation, which are pictured here. All right, three main kinds. There are other kinds, but there's only three that you need to know about for this course syllabus. If you ever take more physics and learn more about nuclear radiation, there are other kinds besides this. But this is the kind that we're going to talk about, these three. All right, so that's what this video is about. What are these? How can we define them? And how do they behave? So here we go. First kind of nuclear radiation is called alpha, an alpha particle or alpha decay. And basically it's this. Unstable, usually quite large nucleus, lots of protons and neutrons, decays because it's unstable, and it emits a particle from the nucleus. This particle is the alpha particle. And what does it have in it? It has, well, two of these blue things and two of these red things. It's got two each of two different nucleons. So two protons and two neutrons, which I don't know why I just wrote that out. It's actually typed out here. So two protons, two neutrons. All right, bam. Two protons, two neutrons. There they are. So that it's basically a helium nucleus. All right, without the electrons. So it's a helium nucleus. All right, so that's what a alpha particle is. Two protons, two neutrons, helium nucleus. So what else do we have? We have a beta particle. A beta particle is quite simply one electron, but it's not just an electron, because as we were talking about, electrons orbit the nucleus in a cloud of orbitals. So they come around here. There's just this cloud of electrons in various energy levels and orbitals, right? We generally just draw it as orbits because you can't draw a cloud. But in any case, so you've got all these electrons going around here. Here's the trick. This electron that's a beta particle does not come from these orbits. It's not one of these orbiting electrons that just like comes off. This electron actually comes out from the nucleus. And you say, wait, what? There aren't any electrons in the nucleus. And you are exactly right. There are not any electrons in the nucleus. Here's what's happening. It's really bizarre. A neutron in the nucleus decays. It's unstable, right? The nucleus is unstable. So at some point, a neutron in there is going to spontaneously decay into a proton. What? A neutron turns into a proton and it emits an electron. What is that? What? Well, if it helps you to think about it this way, you could think of a neutron as kind of like an electron and a proton squished together to make a neutral neutron. It's not really accurate, but it kind of is kind of like that. So if you think of the neutron as a proton squished together with an electron, then when the neutron decays, you can kick out the electron and you get a proton left behind. Anyway, that's basically what happens in beta decay. Electron is emitted from the nucleus, and it now is called a beta particle. Okay? There is beta decay. Last one is called gamma, Greek symbol gamma. And guess what? It's just energy. Gamma radiation is basically electromagnetic radiation that's very high energy, so it is very dangerous. But there are no particles. It's just pure energy. So this is pure energy. All right, those are the kinds of decay. So what can we say about them? Well, how do we block them? I'm going to go through this really quickly. You can look back at it again if you want, rewind the video or what have you. So the question is, how can you shield against nuclear radiation? And what is their ability to break through shields? So let's start with alpha. Alpha radiation, it's kind of big, right? Compared to the others, it's an entire helium nucleus. It's by far the biggest of the three kinds of radiation that we're going to talk about. So not surprisingly, it's stopped by a very small shield. In fact, a sheet of paper is sufficient for stopping alpha radiation. All right, you may be surprised by that, but really, just a sheet of paper will stop most alpha particles and will protect you from the alpha radiation. Your skin is pretty much thick enough to protect you from alpha radiation, if it's outside your body. So what about beta? Beta particles are smaller. They're an electron, just an electron, so that's way, way smaller, thousands of times smaller than an alpha particle. So harder to stop these guys. So let's take a look at what it takes. Beta radiation has to be shielded by aluminum, basically. Something like aluminum or possibly stone if it's thick enough. Lead definitely works. Lead works for all of them. All right. A small amount of lead is sufficient for beta radiation. Relatively small amount of lead, relatively small amount of aluminum also works. So a lot of metals will shield from beta, and definitely lead. Gamma. Since gamma is pure energy, you might guess it's not a particle. There's nothing to hit, right? It just has to be absorbed by matter in order to stop it. So gamma is the most penetrating. Gamma goes through almost anything. So what you need to stop gamma is a thick chunk of lead. That's the only thing that can stop gamma radiation. Thick lead. All right? Okay, so here's a comparison chart to sum up the different kinds of radiation. All right, alpha particle, relatively large, ability to break through shielding, it's very weak. Can it be bent in an electrical magnetic field? Yeah, it has an electrical charge, so it can be bent. And we'll talk more about this later. For now, just know yes, alpha radiation can be bent in electric or magnetic fields. Here's something that is new for this slide, ionizing strength. How much does it ionize things? What do I mean by ionize? It means cause things to have a plus charge or a minus charge. Ions have a plus charge or a minus charge. Things that are not ions are neutrally charged. They have no net charge. So alpha particles, having 2 protons, they have a +2 charge. Beta particles only have an electron. They have a -1 charge. And gamma is uncharged. So looking at this, which of these do you think is likeliest to cause ionizing? And the answer is alpha, because it has the largest charge, +2. So alpha is the strongest ionizing radiation. All right. Beta is moderate, second strongest ionizing, and then the weakest at causing ionizing is gamma. All right, because gamma doesn't have a charge. It can still ionize things, but not as much as the other two. So let's go to beta in terms of some other things. Ability to break through shielding. It's moderate to strong in its ability to break through shields. All right, you need relatively robust, thick shields to block beta radiation. Can it be bent in an electrical or magnetic field? Yes, because it has a charge, right? And it's moderately ionizing, weaker than alpha. Gamma, very strong ability to break through shielding. No, it's not deflected in an electric or magnetic field. It just goes straight through as though the field were not there. And it is not very ionizing. It's weaker. It does cause damage, though, so you have to be really careful with all of these radiation if you are exposed to them. Okay, really briefly, how do we detect radiation? Basically, we use this device called the Geiger counter. The details of this are really not that important, but I'll just show you very briefly the basic idea. Ionizing radiation comes through this window here. The window is usually opaque to light. It doesn't let light through. You can't see through it with light. but it is transparent to ionizing radiation. So the ionizing radiation goes straight through. Alpha particles, beta particles, gamma rays, they all just go straight through this window as though it were not there. So they go bam, right through there, and then they're going to interact with the electrical properties of this tube, basically the Geiger tube. This is what it looks like on the outside. This is kind of a schematic view of the inside. Basically, the ionizing radiation causes ionizing in here, and that causes the circuit to spark and registers as a count and a click. So you'll hear a click, 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 click. One click for every time that you get an ionizing radiation particle going through that window, and then it shows up as a count on your counter. So that's basically it. Basically using some electrical properties, very high voltage inside here in order to cause that click, click, spark every time there is an ionizing particle that goes in here, and then it shows up on your counter. Cool. All right, safety precautions. So if you happen to be a person who works in nuclear industry of some variety, then you'll need to take some precautions. And here are some reasonable things that can be used in order to protect yourself from nuclear radiation. So the first one that I have pictured here is a personal radiation counter. So you carry this around on your person wherever you go if you work in a place that has nuclear radiation, and it will keep track of how much radiation you have been exposed to. All right, so any place you go that has radiation, this thing also gets hit by the radiation. It detects it, and then it will tell you the dosage of radiation that you've been exposed to. And when you reach a safe limit, you basically have to stop going into any areas that have radiation for a while, because there's a maximum dosage you're allowed to have, and then you can't have any more. Or it's not safe. It's not considered safe. Another thing, basically giant lead blocks to shield everything from yourself, right? So these are thick pieces of lead that provides good shielding, so you're pretty safe from any radioactive source if you've got all this lead. All right, so shielding is another thing. Monitoring your dosage, shielding, wearing protective clothing if you have to be in an area where there is radiation, nuclear radiation, so you wear the protective clothing. And then lastly, and actually one of the best ways, is distance. So if you've got a nuclear source of radiation, then basically the further away you are, the safer you are, because all of them have a limited range. All kinds of nuclear radiation have a limited range. So if there's a source of radiation sitting there, the further away you get, the weaker the radiation gets. So this guy here, he's in the most danger. This guy would be second most danger. Then these guys here, these guys, and these guys are the safest from the nuclear radiation because they're the furthest away. So those are the key things to think of when you're thinking of nuclear radiation safety. All right, just keep track of your dosage and get out of there when you get too high of dosage. Protect yourself with shielding. Protect yourself with proper clothing and mask filters so that you're not breathing it in. And then just stay far away as possible. All right, that's it for this video. See you next time.